So we're going to go ahead and dive right in here. And this is a sneak peek at our SANS Secure DevOps survey. And it's a sneak peek because it's not going to be published until November, until next month. And so the folks are still working on it, polishing up, but they shared with me the paper ahead of time. And so we're going to give you a little bit of a preview as to some of the results. Now, word of warning, though, this talk is not going to be just all of the survey results. Interspersed within here is going to be a little bit about some tools and some other best practices that we want to think about from an overall DevOps perspective. So just a quick bio here. I'm not going to go over this, right? I kind of mentioned this a little bit yesterday, so we'll skip over this. But in terms of the survey itself, the paper that's going to be published in November is called Secure DevOps, Fact or Fiction. And this paper is written by Jim Bird and Barb Filkins. And it's actually an ongoing series. This is actually the first time that we've done a paper specifically asking questions about secure DevOps. But for the last 6 years, we've been doing an annual survey on application security and application security best practices. Last year in particular, we did a survey specifically focused on how organizations from a software security perspective are balancing the speed of delivery with the risk that might be being introduced to the organization itself. So this survey in particular is one that focuses on, well, where are risks in DevOps, in the pipeline itself? How are those risks managed? And what are some success factors in implementing DevOps itself? So throughout the course of this session, it's divided into 3 different topics. Right? Number 1 is a little bit of background at what the survey tells us in terms of DevOps adoption, technology adoption. Number 2 is we're going to have a little section on shifting left, integrating security a little bit more into the earlier CI/CD DevOps pipeline phases. And then finally, the 3rd section, we're going to talk a little bit about moving forward. What can we do in our organizations to kind of shift where we are from a DevOps perspective and incorporate, embed, integrate security a little bit more into the overall process itself. Sound good? All right, I see a lot of nodding heads, but not a lot of vocal response here. Must have been a lot of drinking last night. Yeah, a lot of drinking last night. I taught a class in Vegas one time, and this was a smaller class. It was about 15 people, and they showed up to class every single day of the class, but you could tell they were destroyed, right? They were out all night long, having a good time, but they showed up to their credit. Now, it was a little bit hard for them to pay attention, but, right, so if you guys had some beers last night, had a little fun in the arcade, bowling, you know, that's great. This is why we're all here, to get to know each other a little bit better. Now, from a DevOps adoption perspective, what does the survey tell us? Starting with some basics here, right? We basically asked the question, hey, what % of your applications, what % of your systems do you deploy into the cloud, or do you use containers for, or do you use serverless for? And the different bars here, right? We've got the legend, the key at the bottom. We said, hey, do you use cloud 1 to 5% of the time, 6 to 10% of the time, all the way on up to more than 75%, or even 100% of the time. And if we add all of these numbers up, the respondents, the survey says that 85% are using the cloud, 72% are using containers, and 54% are using serverless. So these technologies, these approaches that we've heard about up to this point all throughout yesterday, is these are actively being used in organizations across various industries, financial services, healthcare, government, and so on. Now, this shouldn't come as a surprise to those of us here in the room. This is just more reinforcement of the fact that, yes, this is actually happening. And what does this mean? This means a shift away from some of those traditional approaches. Jason yesterday mentioned the monolith architecture approach. Now, on this slide in particular here, we see that we've got some AWS constructs, right? We've got a VPC, a virtual private cloud. We've got in the middle here an ELB, an elastic load balancer. In the middle, we've got an EC2 instance. And on the right-hand side, we've got your back-end relational data store in this particular case. Now, there's been a couple instances in recent years where I have witnessed firsthand an organizations said that we want to move to the cloud. We want to become a more modern technology organization, and we're going to do that by moving to the cloud. The problem was that in these 2 examples that I'm talking about, the organizations decided to do a lift and shift. They basically took their existing processes, their existing technology stack, and kind of like we see on the diagram up here, they lifted and shifted that into the cloud itself. Do you think it was successful? Of course not. Has anybody undertaken an initiative or witnessed an initiative like this before? Right, look, I see quite a number of hands go up. Now, part of the reason that this occurs is at the bottom, we see in this traditional approach, your traditional three-tiered architecture, if you will, one of the reasons that we see this lift and shift approach, even sometimes still happening today, is because, well, we know what to do from a security perspective. What do we do at the front end? We've got a firewall, a web application firewall, encryption of data in transit. We've got authentication, authorization, other controls, and we know how to embed these in these traditional architectures. But as we've heard up to this point, well, this has changed. We've got new architectures, new ways of delivering systems, services, and software. On the left-hand side, we've got not just your single basic web application client that might be represented by your single page app at the top, your Angular, React, your Ember application in the middle. On the left, you've got your mobile applications, and even perhaps in the lower left-hand corner, your IoT devices that are talking to various services here in the middle, no longer your simple monolithic application, that are then talking to various different data stores. On the lower right-hand side, you might have your S3 bucket, you've got your EBS, Elastic Block Store, and you've got perhaps still your traditional relational databases. Now the catch, though, the problem with this is what? Increase in complexity here on the next slide. Now you've got a ton of different interconnections, and we're going to talk a little bit more about attack surface as it relates to the threat model a little bit later. Now, can we take, as people have mentioned, those traditional security controls that we just mentioned 2 slides ago and apply this to this environment? Is it going to work? No, not really, right? Not like we perhaps have envisioned. And so when you are moving to an environment like this, well, that means we've got to move faster. We've got to deploy faster. We've got to keep up with this velocity that's been mentioned before. Now, the survey in particular, what does it say about people's ability to move fast? There's a couple interesting data points here. Down at the bottom, we are comparing in the red the 2007 survey results, 2017, excuse me, to the 2018 survey results. How many people are deploying what we called, quote unquote, continuously, multiple times a day? And you can see last year, only 5% of respondents said that they were deploying continuously. But that number has doubled in terms of the survey respondents this year. Also, the people that are deploying more than once per month. Now, that has increased, right, from approximately 17, 18% to 25%. Now, when I started my career some 20 plus years ago, right, as a developer, as an engineer, I was working on a system, and I was at this big bureaucratic insurance company, a slow-moving insurance company. Any guesses, now that we've got that context a little bit, any guesses as to how many deploys we did in that organization, for this particular software development project? How many deploys did we do a year? 4, 1, 2, 0.5. Ben has it most closely. When I thought about this in retrospect, we did 0.7 deploys a year. 0.7 deploys a year. It was ridiculous, right? We would have to get the whole team together and over a weekend push out this software to all of our sites around the country. And who hated this? Who hated this? Everybody hated it. We, the developers, we, the engineers, the security team hated it. The business hated it, right? Because they couldn't get features and functionality as fast as they wanted. And so now we see a shift, even year over year, right? 66 versus 60%, if you add up all these numbers towards the bottom of the graph, are deploying now more than once per month. We've got this constant increase in velocity that we're going to talk about more as we get to the end of the session. So how is this velocity enabled? Well, people have mentioned earlier Jenkins, your CI/CD pipeline, which is the backbone, if you will, of your DevOps processes. Here, we like to break down the DevOps process, the DevOps pipeline, into these 5 key phases. On the left-hand side, we've got your pre-commit, right? Things that occur, things that you can do before code is actually checked into version control. The commit phase, once you do a git commit and a git push, that then the code gets pushed up to version control, starts off your CI, continuous integration process. Then as it moves along the process into your acceptance phase, where you've got various continuous delivery practices, and eventually getting that code, that application, that system, pushed to production and corresponding post-production activities in terms of your ongoing operations. So we break it up into these 5 basic phases, right, to make it more easy to conceptualize this, because here on the next slide, well, what are some of the security practices that we want to think about embedding injecting at each of these various phases of the DevOps pipeline. And we list some of the security practices here because these are the phases at which you want to at least start to have these different security practices. Now, I'm going to ignore pre-commit for a moment here because we're going to talk more about that in detail in an upcoming section. But if we take a look at the commit phase, right, you've got things like static code analysis, your SAST, static application security tests, your security unit tests. Quick show of hands here. Who here has some security unit tests in their organization? All right, a handful of folks. Just like you do your normal security, normal unit tests to check for basic functionality, ideally you want to incorporate some security unit tests to validate at a basic level in the commit phase, right, what security functionality features are actually in place or not. Dependency management, right? Somebody mentioned, I think, Equifax earlier, and we know that Equifax, one of the reasons in the news, in the press that came out that why they were exploited was because of a Apache Struts vulnerability that allowed remote code execution. Classic example of dependency management, or the lack thereof in that particular case. In the acceptance phase, this is where you might want to start to incorporate additional dynamic security tests, DAST, dynamic application security tests, other acceptance tests, and so on. And you can see as you are progressing through this, which is the phase by which you want to have some of these different security activities in place. Now, if we keep the concept of that pipeline in mind overall, now this eye chart, it's a little hard to read. That's why we've got the link, the URL, the shortcut URL down below. This is our SANS Secure DevOps tool chain poster. At the top, which you can't read, it's broken up into those 5 phases, the pipeline phases that we just talked about. And in the spirit of kind of this last day of the conference where everybody is talking about different open source tools, we have listed at the top of this poster a ton of different open source tools that you could potentially utilize for each of the different 5 phases up at the top. Right, you can get a higher resolution PDF version of this down below. Anybody seen this before, by the way? I'm just curious. Just a handful of folks? And you should have one in your bag. It seems like many of you haven't opened your bag up yet, right? But definitely check that out, right? So this is your Secure DevOps toolchain poster. Now, if that's the overview of what are some of the security activities that you can embed, inject into different phases of the pipeline, well, one of the key indicators, right, of how well we might be doing is our speed of assessing, frequency of assessing or testing business-critical applications. And in the survey, well, we asked this question again. In 2017, we asked this. This year, 2018, we asked, hey, how frequently do you assess your business-critical applications? And down at the bottom, that continuously that I mentioned before, multiple times a day, right, you can see it was approximately 12%, but now almost 25% of organizations are testing on a continuous basis. And in the middle, more than once per month, right, we've got approximately 12% all the way up to 25 as well. And so you can see that the velocity of the security, it seems, at least from the survey results, is seemingly keeping up with the pace, at least from an assessment perspective, right, of the deployment speed that our organizations are moving. But we know that it's not just about assessing, right? We in security, we're pretty good. We're pretty great at finding issues, finding vulnerabilities. What are we not necessarily so great at? Fixing them, remediating them, right? And so this gets us to the next section here in terms of shifting left, right? How can we do a little bit more comprehensive, thorough job before we circle back to remediation at the very end of the session here? So the next question we said is, okay, well, if you're pretty good at finding vulnerabilities, right, well, when do you inject, when do you introduce security into your development process, into your pipeline itself? And on the right-hand side here, when we asked, well, when do you involve security in your major projects, there was a small percentage on the far right that said, we don't actually know, right? That's a big problem. That's not good. But there is approximately 14% of folks that say we inject security, we work with security just as needed. But if you go further to the left, you can see that, okay, implementation, QA, during the development phase of the project. But there are quite a lot of people that incorporate security in the requirements phase and in the inception phase, approximately 23%, right, for each. That's good. That's good news, right? I would venture to guess that if we had asked this question 6 years ago, those percentages would have been a lot lower. Now, the flip side of this, though, is I got the glass half full, I got the glass half empty. When you add up those two, inception and requirements, well, only about half, less than half, 46% of folks are actually incorporating security, right, involving security early on in the development process. And this is what we talk about when we want to move further left. And if we go back to the pipeline here itself, you really can't get conceptually any further left than pre-commit, right, from a pre-commit perspective. So in this next short section here, right, let's go ahead and dive into just 3 of these items from a pre-commit perspective. The first one here is threat modeling, right? So if we take threat modeling and think about, well, what activities can we utilize to shift further left into the development process? From a threat modeling perspective, this gets back to thinking about your attack surface, right, your trust boundaries. Some time ago, I was doing an assessment, a test of an application. And we discovered that there was a front-end web application, and there was a back-end set of microservices. Well, when we were testing this, turns out there was a lot of great validation and security checks on the front-end website. But on the back-end microservices, we discovered that anybody could call them, and there was no corresponding back-end data validation. So if you encounter this in your organizations, what's the first thing that you're going to do? Lock down the microservices, right? And how are you going to lock down those microservices? Who do you need to talk to? You need to talk to the development team. So we went to the development team, and we said, hey, this is what we discovered. A lot of good validation on the front end, no validation, open microservices on the back end. And we said, here are some suggestions, right? Access control, authorization, input validation, sanitization, and so on. And when we gave them these best practices, we said, hey, we'll work with you, we'll help you figure this out. What was their response to us? We're too busy. Working as designed, we got it, right? They said yes. They said essentially their response was, this service is working as designed because we know that the web app is the only client that is calling our microservice. So why should we duplicate all of the validation and checks on those microservices when you're already doing it on the front end? Is that a good excuse? No, of course not, because there is a trust boundary being crossed from the front-end web service, web application, to the back-end web service. Anytime there's a trust boundary being crossed, especially we want to ask ourselves, well, what's the attack surface look like? How is that changing? Are you changing the technology stack, right? Are you adding additional confidential data? And what threat agents, what the threat actors, has the landscape itself changed? So what are some tools that can help you with this? Think about this, conceptualize your threat modeling process. Yesterday, Kelly and Nikki talked about a tool that they use that similar to the rapid risk assessment questionnaire that we'll talk about in a moment. But as inputs to this process, there's a number of free resources that are available online. We've got OWASP, right? The Open Web Application Security Project has their security stories. Now, these security stories are pretty cool because it's a pre-canned document set of artifacts that basically say, what are some common security stories that you might want to consider? Like, our application needs to allow users to have a password reset functionality. And this password reset functionality needs to be secure. Not that anybody would ever abuse password reset functionality, right? And so it's got a sample list of stories there that you can leverage. You've also got the second bullet here, the Application Security Verification Standards, ASVS. Who here has downloaded, read, or even used this before? All right, a handful of folks. Now this is some guidance, best practices in terms of testing, assessing applications, but there's also recommendations in terms of developer best practices and mitigations that are defined in this document that then, right, ties your mitigations to your attacks, right, feeding into your threat modeling process. The bottom bullet, OWASP Threat Dragon. Now we saw a tool yesterday, the Threat Playbook. OWASP has kind of conceptually a similar tool called Threat Dragon. Now this is still in alpha stage, but it basically allows you to define what are some of your threat scenarios, and it'll generate some corresponding mitigations for those particular scenarios. Now, lastly, we've got Mozilla's Rapid Risk Assessment. Now, when we in security have traditionally done risk assessments, how long does that risk assessment take? We ask somebody to fill out a questionnaire to start. How long, historically, does it take for the internal team to fill out that questionnaire? 4 hours, the fastest they can get away with, right? Usually it's cumbersome, right? This is why the questionnaire at Slack, that was a really good one, interesting one, because the intent is to have them fill it out as fast as possible. Even if they say, right, in the Slack example, hey, well, we do want security's help, then they stop filling out other questions, right? Well, Mozilla's Rapid Risk Assessment, freely available tool online, it's just a Google Doc, and it's streamlined, right, the risk assessment process to say their goal is to have people be able to fill this out in 30 minutes or less, right? And so this concept here in terms of speeding up activities in the pre-commit phase itself. Now, that being said, let's go ahead and move on to the second topic here in pre-commit, which are IDE plugins. Now, back in 2005, kind of at the early phase, if you will, of commercial static analysis tools, I was heading up an application security team, and we were using some static analysis tools, doing testing, doing pen testing, other activities. And I had this brilliant idea. You know, I thought to myself, this concept of shift left, even back then. I said, you know, we are running this static analysis scanning factory on our code. It's taking a long time. Why don't we give the developers an IDE plugin that they can install in their development tool, and all they have to do before they check in the code is click the scan button, right, to scan their code. And we shared this with the different development teams, right? And one developer even said, this is great, I love it. Right? Did I ever hear from that developer again? No. And that developer, I only learned this after the fact. I'm a little bit slow sometimes, as you guys might have gathered. Right? He was using reverse psychology. He was telling me what I wanted to hear, so I would go away. But the reason that this was a failure was not because, right, people didn't actually use it. When they did use it, back in 2005, they clicked the scan button before checking in code. What happened? Whole bunch of work to do, and the scan took minutes, right? Sometimes, you know, not just a minute, not 5 minutes, sometimes 15, 20 minutes, impacting the development workflow itself, making it harder for the developers. And so we want to make sure now, fast forward approximately 13 years later, there are things that we can utilize, other tools that are much faster. Right? From a Java perspective, well, example, we've got Find Security Bugs that's based on the Find Bugs and Spot Bugs open source project. We've got Microsoft's DevSkim, which is kind of a framework, if you will, right, for doing linting and security analysis checks in some of these IDEs. You've got SolarLint, which is another example of this, and we've got PumaScan here. Now, the reason that I mentioned these, even though this failed for me in 2005, what is different now about some of these tools is, and if we take one example, you know how when you're typing in Word, right, and you make a grammar or a spelling mistake, it gives you the little squiggly line immediately, right? And it tells you, hey, something might be wrong. Well, this is a screenshot of Visual Studio, specifically with the open source PumaScan tool installed, that says, hey, as a developer in the middle here is typing some code, right? They're typing some code, and it gives them a little squiggly line. Now, can anybody identify what vulnerability this is here on the screen? Unsanitized input. And from a security perspective, what vulnerability is that? It's cross-site scripting. Now, do we mention cross-site scripting anywhere here on the screen? Why not? Why not? Because they won't know what it means. Developer doesn't necessarily care about cross-site scripting. So you can see here, we've got on line number 38, we've got some data that is being concatenated, string concatenated with the data coming from the request on line number 37. And this data, when it's sent back to the browser, is going to result in a cross-site scripting, in this particular case, a reflected cross-site scripting vulnerability, similar to the issue that affected both Barack Obama's website and votehillary.org that Ben was talking about earlier. And in the little highlighted box that comes up, it doesn't say you've got a cross-site scripting vulnerability here, but it says you've got some unencoded output. Because we know that the best way to mitigate cross-site scripting is to output encode the data as it's getting sent back down to the browser, thereby preventing this cross-site scripting vulnerability from occurring and resulting in code execution, JavaScript code execution in the browser. So just an example of a secure code spell checker that you can utilize to speed up the process, because this should be seamless from the developer's perspective. All right, now we're still in the pre-commit phase. Let's go ahead and talk about the third approach. And this gets us to the pre-commit hooks. Now, when we are using Git from a version control perspective, Git allows us to define let us run different scripts at different points in the overall Git workflow, like in the pre-commit phase before code is committed, like on the server side, the pre-receive phase and the post-receive phase. So there are various points in our workflow where we can inject some additional functionality. And so some examples of using the pre-commit functionality are like your Yelp pre-commit framework and the overcommit framework that are both free open source tools available online. Now those two frameworks, those two tools are not security specific, right? They allow you to instrument any phase of the Git check-in process, right? But from a security specific perspective, we've got a few examples down here at the bottom that essentially all do the same thing. The company Auth0 has a tool called Repo Supervisor. ThoughtWorks has a tool called Talisman. But we've also got from AWS Labs themselves, on AWS Labs' GitHub page, they've got a tool called Git Secrets. Now, Git Secrets, how does this work? Here on the next slide, right, you can see that in this little snippet of code, line number 1, we are doing a git commit -m. The -m, the message, right, in terms of testing Git Secrets here itself, and the code that we're trying to check into Git. Right? We can see on line number 4, we've got our AWS access key. Right? We've got on line number 6, our AWS secret key. Now, this has come up a number of times in various sessions. If an adversary gets access to this secret key, what do they have access to? Your AWS environment, right? This is access to essentially your control plane. Right now they've got access, depending on the permissions of this particular key, right? They could potentially have access to your entire data center, if you will. So when you try to make this Git commit with Git Secrets installed, well, the cool thing is that as we see from the message down at the bottom, well, you can't commit this code. And so this is mitigating, helping to eliminate one of the big vulnerabilities that Ben previously mentioned on the top 10 top 10 cloud security risks. Right, so a small practical way to mitigate secrets being inadvertently exposed. All right, let me pause for a second. Any questions, any comments on any of the tools or things that we've talked about so far? All right, so that brings us to the last section here in terms of moving forward. Now, we also said, we saw earlier, that it appears that different teams are able to move faster, conduct testing at a faster pace. Well, we also asked in the survey, well, what percentage of your critical vulnerabilities are repaired, fixed, remediated, satisfactorily, and in a timely manner? Now, this is where the news gets not maybe horrible, but not so great. Year over year, 2017 to 2018, we can see that the incremental improvement between these responses is not that much. If we add up the folks that have actually fixed more than 75% of their vulnerabilities, 1% improvement according to the results, 51 versus 50%. And the people that have repaired, right, more than 50% of their vulnerabilities is at a consistent 70%. So although, according to the survey results, we are able to test more frequently, faster, perhaps more comprehensively, we are not actually remediating, fixing the vulnerabilities that are actually discovered. Does this sound like a surprise to anybody? No, right? Maybe not a surprise to most folks, but a surprise to some organizations, right? And so why is this the case? Why can't we necessarily fix faster if we're finding faster? Well, here we said, well, what are your top 3 challenges implementing secure DevOps in your organization? Number 1, shortage of application security skills, insufficient budgeting and funding, organizational silos, continuously changing requirements, and lack of management buy-in. What is the common theme amongst all of these responses? Organizational problems. These are not technology, technical problems, right? And so this is why a lot of times in DevOps, when people ask, well, what is DevOps? There's the common acronym that is discussed, right, created by John Willis and Damon Edwards, right, and later modified by Jez Humble, originally called CAMS, modified by Jez Humble to add the L in terms of calling it comms, right? We've got culture, automation, lean, measurement, and sharing, right? Kind of your DevOps principles, if you will. And so this is why culture perhaps comes first, because most of the things that we see here in terms of inhibiting DevOps progress are not technical. One of the things, though, that kind of bubbles up to the top that is a little bit more technical is the third one from the top, technical debt in legacy systems. Who here's got technical debt in legacy systems? We should mostly all raise our hands. Amazing problem to have. So let's dive into this a little bit deeper. We also then went on to ask, well, you in security, what types of applications do you actually protect? Now, we've spent a lot of time up to this point in the summit talking about the things in red on the far right-hand side, like your container-based applications, your microservices, your APIs, your public cloud-hosted applications. But you can see from the results here over on the left-hand side in blue that most of the time that our security organizations spend are protecting legacy applications, public-facing, legacy perhaps, websites, commercial off-the-shelf applications. And so we're at this critical point, right? What do you anticipate? What do you protect now? What do you anticipate protecting in the next 12 months? Well, the legacy apps are taking much more of our time, attention, and resources, because that's just the state that most of our organizations are actually in. But at the same time, we've got to prepare for the modern attack surface of tomorrow. And what is one example of this? Well, here on the right-hand side, now this is using some AWS constructs. You can see you've got DNS at the top. You've got two different environments, right? Your typical blue-green deployment options. You've got your blue production environment. You've got your green, perhaps nearly identical environment where you might want to deploy some new functionality, features, and fixes, and maybe shift over to that green environment. So in the blue box, right, you've got your ALB, your application load balancer that is directing traffic to various perhaps EC2 instances. And what is down here at the bottom in blue, at the very bottom? Your database. Now, if we define your blast radius is the radius at which your changes are going to impact your overall system. One of the keys to working with legacy systems is defining your blast radius appropriately so you can, right, slowly over time automate more things related to your legacy systems. Is the database down at the bottom, is that inside or outside of your blast radius? I'm sorry, I didn't hear you. Inside or outside your blast radius? It depends what you're blasting, right? In this example, it's intended to show that the database is outside of your blast radius. Now, why is the database outside your blast radius? Well, perhaps this is your legacy, right, system of record, relational database that has been around for many years, perhaps decades in some cases. And when you make a change to that database, if it's not just a data change, if it's a DDL change, if it's a schema change, is that going to be easy to automate? Generally not. Generally not. And so this is here from a legacy system perspective why we define it to be outside of your blast radius. All right, so if we keep that in mind and we shift gears here a little bit, and then we say, all right, if those are the challenges, that you're encountering, well, what are the top 3 factors that have contributed to your success? Pick 3. Well, number 1, folks said that is integrating automated security testing. Now, that shouldn't be a surprise because the earlier survey question basically indicated that, hey, we are able to move faster from a testing and assessment perspective. But some of the other things that are mentioned here, what has contributed to your success? Developing security champions, training developers, securing management buy-in, creating cross-functional teams, sharing goals across teams. Now, just as before, right, all of those fall into which category? Are those technical items that you have to implement? Organizational items, right? More cultural items that help inform your security team's success. And yesterday, if we remember back to the keynote that Jason gave, right, at the end, somebody asked a question, right? Well, but how do you start to do this in my organization? How do you do this? How has this been successful? And Jason, I don't think you used the word culture at the time, right? Or I think you did, but you said, well, this is related to Netflix's culture of, anybody remember the 2 words that he used? Freedom and responsibility, right? And so these things that we're talking about here are dependent on your organizational culture. And so if we are thinking about moving forward from a DevOps perspective, now here, imagine that you are a relatively new security team. Who here, quick show of hands, who here feels that they've got a very mature DevOps, SecDevOps program? Some of the speakers should raise their hands, no? Right? Who here feels that they're kind of middle of the road, kind of making their journey? All right, who here feels that they're very early on? The vast majority of folks. Now, if we think about us from a security team perspective, wanting to work more effectively with the development team, in this table, we've got 4 different examples of things that we in security could do or have done in the past. And so if we want to push forward our security activities in our DevOps program, right, if we take some of these activities, provide the development team with secure coding standard, identify training that the development team should attend, providing a budget for a dedicated resource to help implement security in the SDLC, or the last one, supply working code that fixes the vulnerabilities. Based on everything that we've heard so far this week, today, the last 2 days, which of these 4 options do you think would be the most effective at getting developer teams buy-in terms of integrating security into DevOps? Is it number 1, secure coding standards? It's okay if you want to answer, right? Who here has secure coding standards? Right, quite a number of folks, right? I saw 1 person raise their hand. What about number 2, right? Identify secure coding training that developers should attend. Is that going to help move the needle? No? Some yeses, some yeses. Number 3, providing dedicated budget. Now this is, I see a couple people raise their hands, right? I've got a colleague, right? He took over a role as CISO. I don't think he'll want me to mention the details here at this point. But he took over as CISO, and he found, like many organizations, it was difficult. It was hard to push the security agenda forward. This was a large, federated organization. Each of the lines of business had a lot of autonomy. And he found that even though he was trying to get his team to engage with them and work in a collaborative way, there was natural organizational resistance. So what he decided to do is he said, you know what? I'm going to go ahead. He went to the different line of business leaders, and he said, I'm going to take out of my own budget, I'm going to provide you a dedicated security SME, a dedicated resource to do these engineering activities, and they're going to have a solid line to you, and a dotted line back to me in security. Right? Did this work? In his particular case, it worked really well. It changed the tone of the conversation and the perception of security. Right? And the reason was, in that particular organization, in that particular culture, right, it worked, it changed because he showed some vulnerability. Right? He showed some skin in the game. He invested his limited resources into trying to improve the overall state of security. Now, what about the last one here? Supply working code that fixes the vulnerabilities. Quick show of hands. Who here thinks this is going to help move the DevOps conversation forward? All right. I think that one is the winner by a slim margin, right? By a slim margin. Now, that one in particular, I agree. I personally believe that that is one of the things that if there's enough security team experience and knowledge to be able to do that, right? Because everything is code now, right? If we can provide that expertise, well, that's going to help develop the relationship. Now, the catch, though, is every single year, I meet hundreds of different security leaders, managers, and engineers, and security practitioners. And when it's outside of a DevOps event like this, it is a very small percentage that thinks that that is even an appropriate conversation or topic to have in terms of their enterprises injecting security into the DevOps pipeline. Why do people feel that way? You break it, you bought it. Yeah. Aaron, I see you shaking your head. Why is there that perception? Skills deficiency, right? There's a question of ownership, right? There's a question of capabilities, right? And I would argue that it's a question of lack of familiarity, right? Security teams for the last decades, have we had to do this? No, we haven't had to do this, right? But what is changing now, as we've seen from talks the last couple days, is the landscape is changing around us. And so this is kind of the direction we're not going to have to, but we're going to be forced to move into, right? To slowly adopt more and more of these types of practices. Now imagine, let's shift gears for a minute. Imagine, a lot of you just mentioned, raised your hands a few moments ago and said, hey, we feel we are very early in the DevOps adoption curve at our organizations. So imagine that you've got to put together a case, a justification, a business case for why your organization should adopt DevOps and secure DevOps, embedding security into the process itself. And you might come up with a justification like this. Well, by implementing a SecDevOps program, it's going to allow us to deploy faster, perhaps up to 25 times per day. I just chose that as an example. It's not as fast as the peak 150 times a day at Slack, but let's say 25 times a day. Therefore, we reduce the lead time for security changes and lead time to repair. That's great. reducing the window of exposure, and we are reducing the change failure rate. Idea being that anytime you deploy a change, well, some percentage of those changes is going to fail. They're not necessarily going to succeed. And so in this example, right, we say we want to reduce that to 12%. Quick show of hands. Who here feels this is good justification? Couple folks. What is wrong with this justification? That's right, AJ. The business people don't understand the value. Yes? Uh-huh. Yeah, certainly. So we can, perhaps dive into a little bit more detail about what exactly these metrics mean. Now, these are good metrics, measures, to help us identify, are we making progress? But AJ raised a good point here. Well, there was two questions. Number one, well, where does this data come from? Right? So let's go ahead and start with that. Here on the next slide, if you read the bottom, right, this is an example that DORA, organization called DORA, DevOps Research and Assessment, has come up with. They've published a number of great things over the years, including the annual State of DevOps report. But they have a research paper called Forecasting the Value of DevOps Transformation and Measuring the ROI of DevOps. And here in this paper, they give some examples of how you might go about calculating ROI for those different metrics that were just mentioned on the previous slide. But we also go on to say, as AJ just mentioned, right, the thing that is wrong from a business perspective with the previous metrics, it's not that that's bad, we're going to have those, but what was missing is the business impact. Right? So in this example, we say, the previous slide, we said, hey, by implementing a Sec DevOps program. Well, I would argue that if you're not a technologist, most business people, they don't know what DevOps is, they don't care what Sec DevOps is. Right? So here, we talk about more general terms, like digital transformation, if that's what's used in your organization, right, a more broad term. This allowed us to perform 165 experiments during our peak tax season, resulting in an increased conversion rate of 50% and increased revenue of $120 million. So we're doing all of this stuff to move faster, but the key thing here is to remember, well, what does it mean from a business perspective? How do we tie this back to, right, the different options that we are going to provide from a business case perspective? Just like when we buy something online. Right? They don't give you one option. They say, you want the $10 a month, $20 a month, or $30 a month plan. Similarly, when we make our case from a Sec DevOps perspective, we want to give multiple options, let them choose one, we'll still have our recommendation, but highlight the trade-offs, right? The trade-offs between business value, risk reduction, and corresponding cost. And so just in summary, here, we talk about these things. The survey results help illuminate some of these items in terms of, one, automating everything, because these changes, adoption of new technology is already here. We need to keep up with this delivery speed. We want to, two, shift left as much as possible, embedding security into that DevOps pipeline. And then number three, focus on the outcomes, right? Balance those technical and organizational initiatives to make your program successful, but focus on the business benefits and not just the technology itself. So if you're early in your DevOps, Sec DevOps program, right, keep this in mind as you're trying to come up with your justifications. All right, so that was the three things that we wanted to cover in this particular session. All right, well, thank you, everybody. We are going to go ahead and introduce our next speaker now.